Okay, so we're going to be using spearmans rank correlation test. So now there's two variables that were measured for each of 8 Olympic male water polo players during competition. We tested the mean heart rate over the 4 quarters of the game, expressed as a percentage of maximum heart rate, and then the maximum oxygen uptake, which we call it VO2 max. Similarly, that are shown in the table below. So there's 8 players that we tested. Now rank the data and then calculate the R squared to verify the results shown in the printout. Rank the data from least to greatest. Assign tied measurements, the average of the ranks that they will receive. They were unequal but occur in successive order. Now for our notes, I'm going to ask you to find the sum of the square differences, which is the sigma d squared. We're going to find the sample size, which is n. And then I'm also going to find out what's n squared minus 1, okay? Because then we're going to use that to calculate the value of r squared, or we'll call it rs. We're going to use the formula 1 minus 6 times sigma d squared over n times n squared minus 1. Okay, so first of all, I'm going to use Excel. I'm going to copy my data here. So I'm going to say I'm going to do my HR. Let me leave the 2 spaces here. And then I'm going to do my VO2R. Let me see for my HR, my data. I'm going to copy my data, 54, 58, 69, 68, 74, 78, 79, and 88. Good. For my VO2 square, I'm going to do 146, 157, 160, 180, 180, 182, 195, and 198. Okay, so I have 8 numbers from each of them. So not looking at just the HRs, there's 8 numbers, and I'm gonna rank them. So 1 is the smallest, 8 is the biggest. So let's see, which one's the smallest number? 54. So I'm gonna call that 1. And then we go to 58. That's gonna be number 2. Then we go in the 60s. Let's see, 68 is my number 3. 69 is my number 4. Then on the 70s, 74 is my 5. 78 is my 6. 79 is my 7. And 88 is my 8. So I label them from 1 to 8, 1 being the smallest and 8 being the biggest. So I rank them. Now let me take a look at my data on VO2. I'm gonna do the same. 1 is the smallest, 8 is the biggest. Funny thing, this one's in order. 146 is 1, then 157 is 2, 160 is 3. Now here I have a tie. So instead of calling them one of them 4, the other one is 5, I do the average of them. So 4 and 5, the average of 4 and 5 is 4.5. Remember how to do the average of 4 and 5? You add them up and divide it by how many numbers you have. So 4 plus 5 divided by 2. 9 divided by 2. Okay, so 4 and 5. Then this is 6, this is 7, and this is 8. I rank them from 1 to 8. Okay, now here, let me do D and then D2 for D squared. Okay, what does D mean? I'm gonna subtract the rankings. So let me go equals. I'm gonna go this ranking minus this ranking. I'm subtracting the rankings. And then my D squared, I'm gonna go equals is basically my D, my difference multiplied by itself. So I'm gonna go 0 times, and then here again, Okay, so here, let me highlight these two. Remember, I left click, I held it. So to highlight, I let it go now. Now here where the point is, I left click and I drag this. Okay, so what did I do? I subtracted my rankings. And then here I squared the rankings. So here at the bottom, let me go equals sum. Let me add these because that's my sigma of d squared, which is 3.5. Okay, so let me come back here to my information here because here it's asking me, remember, this part will be for the homework, for the notes only. For the homework, I'm not going to give this to you. You guys should be able to figure it out. My sigma d squared, it was 3.5. And the sample size is n. So I had 8 numbers, so my n is equal to 8. Now 8 squared minus 1 is 63. Right? Because 8 squared, I know n is equal to 8. 8 squared minus 1 is 63. Why do I why do I know why do I need this? Because I'm gonna calculate this. I'm gonna calculate my r squared using this formula. So I'm gonna go 1 minus, on the top of the fraction, I'm gonna go 6 times 3.5 over 8 times 63. Then I'm gonna use a calculator. So in fact, I'm gonna use Excel as my calculator. So I'm gonna go equals 1 minus, I'm gonna use parentheses. I'm gonna use parentheses for the top of my fraction. And the top of my fraction was 6 times 3.5, which is this number. Close parentheses, divided by, open parentheses. At the bottom, I had 8 times 63. And there you go. It's rounded to 5 decimal places. So I'm going to call this 0.95833. So my r squared is going to be 0.95833. Rounded to 5 decimal places. Now my p-value. Remember how we do this? We go equals t distribution. I need my t to be positive. So the absolute value of t. My degrees of freedom. And then the tails. My degrees of freedom in this case, because I have 8 numbers, my degrees of freedom is going to be 6, right? 8 minus 2. My tails in this case is going to be 1 tail. How do I know? Let's take a look at the alternate hypotheses. Well, looking at this, there's a difference. So there's a difference. So basically, I'm saying my alternate hypotheses is that my beta 1 is not equal to 0. Oh no, it's greater than, I mean. So there's a difference. That means 1 tail. Okay, so we don't have a t value, right? Okay, let me give you a formula for your t value. Our t value is going to be our radius squared, our r squared, times the square root of n minus 2 over, at the bottom, we're going to have the square root of 1 minus rs squared. Okay, so let me go back to Excel. Let me remind you of the formula that I said for t is going to be my rs, which we have, Oh no, that's not my RS. My RS is right here, times the square root of n minus 2, but remember how n is 8, so the square root of 6 divided by, I'm going to do the square root, and at the bottom I'm going to do 1 minus RS squared. Okay, so let me do here. This is going to be my T. I'm going to label this. I forgot to label this earlier. This is my RS. So here's my T equals. I'm going to use parentheses. So for the top, I'm going to put all inside parentheses. So let me just emphasize. I'm going to put all this inside parentheses. And I don't need to put the bottom inside parentheses. So coming back here, I have RS times SQRT, square root of 6. Close my square root of 6 and then close it again. Divided by, then at the bottom I have another square root, so SQRT, open my square root, and inside I have 1 minus RS times RS. So my T value is 8.21778. So for my P value, I have to go equals T distribution. Because my T is positive, I can just click on it. Now, what if it was not? Let me erase this. What if it was not? And I would have gone ABS, absolute value of T, close to value. If I do the absolute value of a positive, still stays positive, right? My degrees of freedom is 6, comma. The tails, it's 1. Close my parentheses. So you guys see the formula. So my P value, ooh, there's an E. So what does this mean? It's as if I had it in scientific notation. I have 8.76203 times 10 to the negative 5. That's what the E means. Okay, so what does that mean? Basically, I need to move the decimal 5 places to the left, right? All right, so let me add some zeros here. Probably I added more than I need. I need to move it 5 places to the left. So 1, 2, 3, 4, 5. So this gives me 0.0000876203. That's my p-value. Now my p-value says I have to round it to 5 decimal places. So I'm going to call this 0.00009. I want to run it to 5 decimal places. Good, not bad. Now we're going to do something else, another question here. A study was done on the effect of massaging boxers between rounds. 2 variables were measured. On the boxers were blood, lactic level, and the boxers' perceived recovery. Okay, so I want my recovery to be my X value and want my blood lactic level to be my Y value. I know it's given there differently, so we got to switch it. The data for the 16 5-round boxing performances are shown in the table below. Okay, So let me go to Excel and let me copy these variables. Okay, so I copied my values, my X and my Y values. Remember, X were my perceived recovery and my Y were the blood lactate levels. I cover them. And notice I left 2 spaces in between because now on my X values, I'm gonna rank them. There are 16 numbers. I'm gonna go 1 is the smallest number and 16 is the biggest number. So number 1, the smallest number is 5, so that's 1. And then 7, 7. So instead of calling one of them 2, the other one 3, I'm gonna do the average. The average of 2 and 3 happens to be 2.5. And then 12 is my 4. And then 13 is my 5. And then I have an here again, the average of 6 and 7, because there's a tie. The average of 6 and 7 is 6.5. And then this is my 8. And then I have another one here. The average of 9 and 10 is 9.5. And then this is my 11, 12, 13, 14, and then here, average of 15 and 16, because these two numbers are tied. The average of 15, 16 is 15.5. Now let me go here. Again, I'm gonna go 1 is the smallest number and 16 is the biggest number. So my smallest number is 3.1. So here's my 1. My second smallest number is 3.4. My third number is 3.7. Now 4.1, I see 4.1 here and 4.1 here. So they're tied for fourth and fifth. So the average of fourth and fifth is 4.5. Then my sixth numbered is right here. My seventh numbered, seventh smallest numbered. And then 5.1 is my eighth numbered. Now for my ninth numbered, I will go 5.2, but there's another 5.2. So there's the average of 9 and 10 is 9.5. Then my 11th numbered is 5.7. And then my 12th numbered is 5.8. Then my 13th numbered is 5.9. Then my 14th numbered is 6. And then 6.2 is my 15th numbered, and 6.5 is my 16th number. Again, I was just going from 1 being the smallest and 16 being the highest. And I should be able to find our square. How do I do this? Let me see here. I'm gonna do D and my D squared. So I'm gonna go equals my difference. I'm gonna go this number minus this number. I'm subtracting the rankings. And then here I go this number times this number. I highlight these because I want the formulas to be repeated. And then here at the bottom, I'm gonna go sum, and I'm adding my D squares. Let me remind you, what was the formula that we did for RS? Let me write it here at the side. RS, the formula was 1 minus 6 times sigma of D squared divided by N times N squared minus 1. My N is going to be 16. My sum of D squared, we have it there. That's what this is. My N, again, is 16. My N squared minus 1 is basically 16 times 16 minus 1. So I'm going to call that 255. So my RS, I'm going to go 1 minus, then I'm going to do 6 times 194.5 divided by, and at the bottom I have 16 times 255. I'm going to do all this using Excel. So I'm going to do parentheses top and bottom so it doesn't get confused. So let's see. My RS going to be 1 minus parentheses 6 times this number, close parentheses, divided by, open parentheses, 16 times 255. So there, my RS. If I have to run it to 3 decimal places, I'm going to call it 0.714. Now give a practical interpretation of this. The rank correlation coefficient shows that there's a relative strong positive correlation because it's a high R squared, right? 71.4%. Now we're gonna test this. My alpha is gonna be 0.01, but here, let me take a look at my alternate hypotheses. It is not equal to, so that means I have a two-tail hypothesis, a two-tail relationship. So I see some alphas here at the bottom, when in reality, because it's a two-tailed, my alpha that I'm going to be using is going to be 0.01 divided by 2 because it is a two-tailed. So in this case, my alpha is going to be 0.005. And then I need my n. My n is 16 because I had 16 values. So I see my alpha that I need here, and I need my n that I need here. So I need this number right here. So here it's going to ask me find a rejection region for a test to determine whether y and x are correlated. I'm just going to say this absolute value of my r squared. I'm going to reject it if it's greater than 0.666. That's the value that I had. Now, what is the conclusion that we had? Look at my r squared. My r squared is 0.714. Let me just write here at the side. My r squared, it was 0.714. And I know I'm going to reject it if it's more than 0.666. It is, right? So I'm going to reject it. So what is my conclusion? I'm going to reject it. There is sufficient evidence to conclude that there is a rank correlation between a boxer's blood lactate level and their perceived recovery. Okay, that's what we did today.